Good morning, everybody. I'm going to talk through resonance today and maybe hit isomers if I have time. And then we guys have a quiz at the end of the recitation. So let's get started talking about some resonance. There's really three basic concepts in resonance. You're either going to be dealing with positive charges, negative charges, or heteroatoms, things like oxygen, nitrogen. I'm unmuted, right? Yeah, okay. And depending, sometimes you have a mixture of these, but these are kind of the general concepts. So I'm going to start with some positive charge examples and kind of walk through that, and then we'll switch to negative, and then do a little bit more of heteroatoms, which tend to be a little bit more complicated. So let's talk about what's happening in general. So positive charge. This is a blank space. If we think back to like we were doing double bonds, we were drawing those orbitals. Here's that green one. Red one, drawing some H's. And then we had these pi orbitals for the double bonds. And what your plus is essentially going to be is an empty one. And because there's an empty space and they're all kind of lined up well, there's no reason that the electrons that are making your double bond can't keep moving into the space that's over here. And this is basically the entire concept of resonance. So if that were to happen, I'm not going to redraw out the whole thing. The two electrons can migrate over. You would fill the bond here. And now there would be a new positive on the other side. And this is what's happening with resonance. So we kind of simplify it 99% of the time. We'll draw an arrow. The arrow is going to be starting from your double bond, because there are two electrons in the double bond, and moving over to the other side here. We're going to draw this double-sided arrow. And we've effectively switched places. So you can kind of think of it as like almost like a door hinge. If you shift the double bond to the other side, there used to be a positive on the right. Now it's going to be on the left. And I'll draw it in with hydrogens to kind of help out a little bit. So So if we have this positive here, that counts as one of the bonds to carbon. So we have 1, 2, 3 for the H's, and then 4 for the plus here. When we do this shift, our double bond electrons can come over. Oh, wait, no. And now we have the same problem on the other side. There's a blank space. We only have 1, 2, 3 bonds to this carbon currently, so it's going to get a plus sign. If, whoops, we expand this a little bit, let's say we add in 2 double bonds, we can do the same concept. So we can move this over. We're starting with the double bond that is closest to the positive and shifting it to kind of close that space there because we have an empty space where the plus is. When that happens, we'll now get a double bond here. The other one was untouched. And because we shifted, our plus is now going to be on our center carbon. And if you think of it as a door hinge, originally you had a double bond here and here with a plus on this side. When we shifted it over, now we have the double bond attached to this carbon and this carbon, which means that there would be a blank space on the other side here. Okay, now we have another option. It's going to be a little redundant because it's symmetrical. Whoops, I get rid of all these. We could shift this another time. Pulling this over. So we didn't touch the double bond that's on the right. We've moved the one on the far left to fill this space. And now we'd end up with a positive over here. Any questions up to this point? Nobody? You guys did talk about resonance though, right?
Yeah.
Yes.
Okay, good. So, oops, what is that? Slowly disappearing. Okay. Something that confuses people a lot is that this only happens for sp2 carbons. So if I break what's called conjugation, if I put my double bond and my plus one away from each other, this is going to be an sp3 center. There's no p orbitals or pi orbitals. So I can't move through that center. There's going to be no resonance in this case. Same thing with something like, I don't know. People often try to like, they see extra bonds here, start moving things from other positions where there aren't double bonds. You're essentially only focusing on, let me draw out a molecule. If we're doing resonance on a molecule like this, you can basically ignore everything except for where the double bonds are and the positive is. So the entire rest of this molecule is essentially inert. You don't really care about it. So for this one here, the only resonance structure we would have would be moving this over. man, that was a rough. Oh, still can't get it. Come on. To get this structure. All right, I'm going to give you guys one, maybe two, to try to work through on your own, and then we're going to go through them together. Oh, rough. Okay, so both of these have a total of 3 resonance structures, including the one that I've drawn. So go ahead and try to draw the other 2. What? What? No. There we go. Okay. Did I mute myself? No, I didn't mute myself. Okay. All right, I'm gonna walk through the first one, and then maybe you guys give you a minute, and then do the next one. So from starting here, I want to take my double bond and try to fill the space where my positive is. So I'm going to shift this to here. And I can start by just redrawing everything I didn't touch. So a 6-membered ring, this double bond, we didn't use that at all. We shifted our double bond, so we can draw a double bond here. We filled the positive that was on the right side, so now we needed that positive on the left side. Our next step is going to be the same. So we can shift the other double bond to fill this space. I'm going to redraw everything I didn't use first. I'm going to move this line for a second. All right. Let's go up here. So we didn't touch this part of our molecule. We shifted that double bond here. So now our empty space is where this positive is. Any questions from you guys? Okay. I'm going to give you guys a minute to do this one. I'm actually going to change. I realized I should put the arrow. This one that's drawn is kind of the middle structure. So I'll do 2 different arrows coming off of this. Make one a different color. So give you guys about another minute, and then we'll walk through this one. All right, so if we start by shifting this left double bond over to here, we can redraw our molecule. Like so. We shifted the left one over, so now we should have a double bond here, and then the positive is going to fill the blank space left over. So because we're at the end of the molecule, this is kind of a dead end point. If we want to do the other resonance structure, we're going to have to go back to our starting material. I'm just going to redraw it again over here. And essentially what we can do is just take the other side. So instead, have the arrow on the double bond on the right, come in, fill that positive charge, and that'll give us our other resonance structure. Any questions on these? The negative ones aren't dramatically different, so you'll kind of get more practice. I just want to, if anyone's got anything, feel free to speak up. Okay, so for a negative charge, we're doing essentially the same thing. The only difference is that now this is a full orbital. Whereas before it was an empty orbital. When you're drawing arrows, you're always starting with electrons. Your arrows will never start with a positive. Before we were using the double bond because the double bond has 2 electrons. We also have this negative, which is made up of 2 electrons. So what's going to happen is that we're going to start here with our negative charge. We're going to come in, and now we're going to make our own double bond. And then when we do that, we're going to kick this double bond out, and it's going to end up as just 2 electrons on this center. So the difference between the negative and the positive, I'll draw out the positive in a second. It's going to give us a structure that looks like this here. Versus if we did this with a positive charge, we'd be starting with the double bond, shifting them over. And you get your positive over there. So the end result is the same. The main difference is these arrows. Is there any questions so far? Anybody out there?
Nope, I don't have any questions.
Okay. Well, I'm hoping this is helpful. All right, so we're going to do kind of the same thing. We're just going to walk through a couple examples. All right, so I am going to start, because I'm dealing with a negative charge, by grabbing the lone pair electrons from my negative, going towards the first double bond I can. That's going to kick the double bond out up to its kind of furthest center. If you're thinking you're going towards it, and it's going to kick it, in this case, to the right. This will give us one resonance structure, which looks like this. So again, we can kind of draw out the part of the molecule we didn't use. We now made a double bond here. Oof. And then kicked the lone pair out to this center. We can do this again. To kick the lone pair up. So part of the molecule we didn't use would be this. We made a double bond here. We kicked a lone pair up to this position. And that would be your 2 resonance structures for this molecule. Okay, I'm going to give you guys a bunch of these to kind of go through, and then we can talk through them together and do some hetero example ones, which are a little bit more complicated. See if we can get examples. Okay, so I'm going to give you guys maybe 5 minutes to try to write out. I believe each of these have 2 more resonance structures. So take about 5 minutes, try to go through them, and then we will go on to some more complicated examples.
Matt, if you're talking, we can't hear you.
Sorry. So for the first one, you can either go clockwise or counterclockwise. You could like shift to the first double bond, or you could shift below. I'm showing the counterclockwise one. So I'll talk to the first one. So if you shift the double bond and kick off that first top one, it would send it to here, giving you, I'll just read all these. All right, so this double bond, going to attack, sorry, this pair of electrons go to attack, kick out the double bond, giving you, so we're just going to redraw our structure. We didn't affect this bottom double bond here. We made a new double bond between the lone pair and the carbon we attacked, which should give us our negative charge in the other position. We can go counterclockwise again. We now made a bond here, giving us a lone pair in this position. So like I said, you also could have done this, which would get you to this, and you can go the opposite direction because these are cyclic. It's going to work either way. Okay, I wrote them down. Let's get the next one. One too many. We've got a positive charge, so we're moving the other direction. We're going to have our double bond shift to close the gap where the positive is. And we can do this again. To get this third resonance structure. All right, next one we're dealing in negative. So we're moving our arrows from the negative towards the double bonds. So we can shift this one in. That's going to kick out this double bond to this furthest position. This is the part of our molecule that we didn't touch at all. We made a new double bond here and a negative here. We can do this yet again. Make a double bond, kick this one up. Oops, I don't want that lone pair. So now we made a double bond here and put a lone pair on this position. Last one should be another positive example. Oh, what did I do? Nope, not that. How do I get rid of this? Nope, I didn't do it. Well, I managed to get myself stuck into something. And now it's gone. Okay, weird. Never hitting the type button again. No. There we go. Oh, man. Okay, so dealing with a positive charge, we're going to have our double bond come in, fill the space where our positive was. That's going to give us a new positive on this branch position here. We can do this again. Shift our double bond. To get to here. Any questions so far?
No.
Okay, cool. So similar to this, when we start dealing with like oxygens and nitrogens, we can have two different things happen. It's really going to depend on whether or not there already is a double bond on your molecule. So let's take this example here. For this, where we already have a double bond here, one thing we can do with an oxygen is an oxygen can handle a charge. So if we were to move this up, what's going to happen is we're going to end up with an extra set of electrons in our oxygen and a positive charge on this carbon down here, because that's going to lose the pair of electrons from the double bond. And now we're just doing normal resonance. So we could chip this over here to get another resonance structure. And these would be the two resonance structures you could get out of this molecule here. So this is when we already have a double bond to our oxygen or our nitrogen. Tends to be how it works. If we don't have one yet, we kind of treat it like it's a, so I guess, yeah, if you have a double bond, you kind of treat it like it's a positive. You're going to be shifting towards the molecule. If you don't have one, so let's take like, this example here, you're going to kind of treat it like it's a negative. Oh, man. Ocean sensor keeps going off on me. There we go. So these lone pairs here can shift down like it was a negative to make a double bond in this position and kick out your electrons to here. And this is going to give us a bit of a charge imbalance, just like the last one did. So we made a double bond here. And we ended up with a lone pair on this carbon here. And this is going to give us a plus on our oxygen and a negative on our carbon. And the reason for that is a lot of electron counting. So typically, oxygen has 6 electrons. You're getting 2 from the lone pair, 1, 2, 3 from each bond. You only have 5, so you're 1 electron deficient. Versus this carbon here, which has 3 from each of its bonds, and then 2 electrons from the lone pair, making it have 5 electrons, and it's supposed to have 4, so it has a bit more of a charge than it's supposed to. From this point, you can just do some normal resonance. So you'll kick these electrons to here, these ones over. The other part of your molecule you didn't touch. Okay, I'm gonna stop here and probably pick this up more on Wednesday, and then we'll do probably Wednesday and Thursday will be first part resonance, second part will be conjugate acids and bases. So I'm gonna have you guys turn on your cameras. We are gonna go through a quiz, and then you guys can leave. So I need to share my screen. So we're doing dipole moments like we talked about on Thursday. So, oh, sorry, ignore these 1 through 10 down at the bottom. I forgot to delete those from the old quiz. Just go through these 5 molecules and draw in the dipole moment.
Do you want us to draw like the individuals or just the net?
Just the net.
Like,
And if there isn't one, just put no net charge.